Hi everybody. Here is an example of some of the answers to the practice test for Chapter 1. It covers exponents and then later on perfect squares and cubes. So thanks for looking at this answer video. Please, if you haven't done the practice test yet, I want you to try it. And then you can take a look at the answers and hopefully maybe you'll be able to find some of the mistakes you've been making and hopefully check to see if you're doing okay. So first of all, let's get started here. First question, basically we have to distribute some exponents. Remember, it's not really the distributive property, but that's the easiest way to think about it. So here's the first question, A. What we need to do is actually take that exponent of 3 and bring it inside to the y to the third, the x, and 3, all three of those things. Remember, each of these things can be separated by multiplication on the inside. So we got to do 3 to the third power, and x to the third power, and then with the y to the third, if we just write it out separately, it would look like this. That is the multiplication rule, so it's y to the ninth. So this is going to be our answer, but any third power, any base that's a number to the third power, like 3 to the third, we want to evaluate that. And that's one of the perfect cubes that you know. 3 to the third is 3 times 3 times 3. That's 27. So it's 27 x to the third, y to the ninth. And that's our final answer. 27 x cubed, y to the ninth. Letter B. On letter B, we don't like negative exponents. We can't have a simplified expression with a negative exponent. Only the x is going to the negative second power, so we need to move the x and its exponent of negative 2 to the top. So the 10 is going to stay where it is, the 5 is going to stay where it is, and that x to the second is going to come up, and remember, when it comes up, it's going to be a positive 2. So here's this last thing. We need to check and see if this is simplified. If you're looking at this, you should hopefully see that 10 over 5 can be reduced further. It's just a regular fraction that we can reduce. So to reduce 10 over 5, we can evenly divide 5 into 10 and 5. 5 goes into 10 twice. 5 goes into 5 once. So this is really 2x squared over 1. Or the best answer, the simplified answer, would just be 2x squared. That'd be the best answer. On letter C, 4x to the fifth to the 0 power. Anything to the 0 power is 1. It's kind of a property that we learned. So that's the answer to that question. But let's say we changed it. What if it was 4x to the fifth in parentheses with just the x and the 5, and then to the 0? So if I change that question, this changes a lot about our answer. Just this part will give us 1, but then we'd still have the 4 times 1. So that answer at the end would be 4. Notice the only thing that's different about those questions is where the parentheses are located. So parentheses really do tell you a lot about certain questions. Part D. Oops. Alright, part D. We have 3x squared times 5x to the fifth. In this one, a lot of us are doing the wrong things with the coefficients. They're just regular numbers. So if we want to, we can rearrange all these things. We can put them, group them together. Oops. We can put all these different things in different orders with the commutative property of multiplication. So maybe that's a better way to see that it's just 3 times 5, which is 15. And then here we have 2x's and 5x's. So if you want to write those out to prove it to yourself, you can. But again, we don't need to because we have that property that says we can add exponents when the bases are the same. So this is x to the 7th power. So it'll be 15x to the 7th. Part E. In part E, the 5 is not being raised to the negative 12th power, just the x is. And remember, we don't like negative exponents. We can't have those in a simplified expression. So right now, those are on the top of a fraction because there's no bottom right now. So you can think about this as a fraction over 1 if you want to. Let's write that again. You can think about it as something like over 1 and move the x to the negative 12 to the bottom. So the x to the negative 12 is going to become positive on the bottom. The 5 stays on top. And if you want to put that 1 there, you can, but you don't need it. In fact, I'm going to get rid of it. Oh, got rid of everything. So here we go, 5 over x to the positive 12. Again, only the x to the negative 12 moves down. Alright, next part here, we have learning target 2, just demonstrate why the properties are equivalent here. Let me zoom out a little bit. And then back in. Sorry. Whoop, that didn't work. Let's try it again. Sorry. Alright, let's try this one more time. There we go. Ah! Did not work. I'm sorry. Well, you can see the question on your paper, but let's see here. My screen isn't working very well. Let's see if I can do this here. Oh boy. Alright, well anyway, we have the question we can see. So anyway, it says we want to figure out and explain why a to the third times a to the fifth is actually a to the eighth. So it says use tables and number models. We can think about a to the third as just a times a times a. Just repeated 3 times. And a to the fifth is really a times a times a times a times a. There's 3 a's and 5 a's. So if you can explain it that way, we have 3 and we have 5. Here when we're multiplying, we have a total of 8 a's. I'll write it out one more time so you can see grouping it this way. So 3 a's and 5 a's. Here we have a total of 8 a's. So that explains why it's actually a to the eighth. It's not wrong to say, well, with the addition rule, we add the exponents and we get x to the eighth. But that doesn't explain why. We want to definitely be able to explain here that there's 3 a's, 5 a's, for a total of 8 a's. Alright, now these exponent rules are getting a little more complex in these next 6 questions. Remember, these are all of our rules that we've learned in isolation, alone, but just combining things. So you're going to look for distributing exponents if you need to. You're going to look for simplifying fractions. That's definitely important at the end. So all these different things we're going to think about. We don't want to have negative exponents anywhere. So those are the things that we need to think about as we're solving these questions. So let's get a little closer here to F and G. Alright, part F here. So right now, right away, I'm seeing 8 and 6. I know I'm going to have to simplify that at the end. So I'll make a fraction bar, and why don't we just go ahead and do that now. 8 and 6 reduces. Both of those are even, so you can cut them in half if you want. If you cut them in half, we get 4 and 3. And that is the simplest form there. The only factors of 4 are 2 and 2, and 1 and 4, and none of those divide evenly into 3. So now if you think about 5 c's on top and 8 c's on the bottom, you know that we can cancel things out. And this is like what we talked about in class, but we know that there are actually 3 leftover c's, and those leftover c's are on the bottom. The subtraction rule says we can just go ahead and do 5 minus 8 with the exponents, and we get negative 3. So if you do it that way, it would be c to the negative third on top, like this. But we don't like that negative exponent, so you'd actually move that down. Sorry, I can't erase. Hang on. Whoops. Sorry, I'll just go and erase it all. So once again, we had 8 and 6, which was 4 and 3. If you subtract them, we get 5 minus 8 is 3, but we know that it's negative, so it's going to go on the bottom. So it'd be c to the positive third on the bottom. Other way to think about it is there's more c's on the bottom than there are on top. So the leftovers, whatever you subtract them, are going to be on the bottom. So that's the final answer there. In part G, here we have to distribute this exponent of 3 here. And we have to take it to a lot of the things inside. We got to make sure it goes to the 2. That's a little big. The x and the y squared. 3 things on top and then the 10 on the bottom. So we need to take it to everything in there. So we'll go ahead and do that. We'll do 2 to the third. Remember, the 2 is just a base. It gets the exponent as well. Then we have x to the third power. And then this rule right here, we're going to multiply 2 and 3. It's y to the 6th power. And this is over 10 to the third power. So now we just need to clean this up, simplify a little bit. On top, 2 to the third is 2 times 2 times 2, which is 8. And then we have x to the third, y to the 6th. And then 10 to the third is actually 1,000. 10 times 10 times 10. And this isn't our final answer. You should be able to see that we don't need to do anything with the x's or y's, but the 8 and 1,000 need to reduce. And before you start freaking out, it's just reducing 8 and 1,000. All we got to do is kind of divide them in half as long as we can, and hopefully that'll get us there. So even though 1,000 is a big number, it's not too bad. So let's start by cutting them in half. 8 in half is 4. 1,000 in half is 500. Both of those are even, so we can go through and cut them in half again. We get 2 and 250. Okay. Both of those are even. Whoops, and on my answer key that I posted online, I didn't do that right. Since those are both even, we can reduce them again. I didn't do that. 2 and half of 2 is 1, and half of 250 is 125. So this is actually 1 over 125. I got that for just reducing 8 over 1,000. And then x to the third, y to the 6th. So if you're looking at the one on Schoology, that is incorrect. I didn't do it. I just said 2 over 250. Sorry about that. Letter H. For H, we're just multiplying here. We do have a negative here, but don't let that scare you. Don't let that think that you need to move it down, because it's just a base. We only move negative exponents. So we're just going to multiply 8 and negative 3 like normal numbers, and that gives us negative 24. Remember, the exponent on A is a 1 right now, since there's nothing there. So we have 1a on the left side and 4 a's on the right side. Add those up. We get a total of 5 a's. And then we have n squared. And there's nothing else we can do with that question. Again, we can't move negative coefficients. Negative normal numbers stay where they are. Only negative exponents move. Alright, going along here. So hopefully you're seeing that as you're working through these, there's a lot of different rules, but we just have to work on how to combine them, and sometimes it's hard to see what everything does when it's all together. But if you look at I, we definitely know that this m to the negative fourth, there's something wrong with that. We need to make it a positive exponent, so we need to move it up. So on the top, we have d to the fifth. The m to the fourth is going to come up and become positive, and the 3 stays on the bottom. The 3 stays on the bottom because only the negative 4 is going to the m, not the 3. If, and that's actually the final answer, but if your question was a little different, let's say it was d to the fifth over, in parentheses, 3m to the negative fourth, then everything in the parentheses would go up. So it would actually be 3m to the positive fourth, d to the fifth, and then distribute that 4, we get 3 to the fourth, m to the fourth, d to the fifth. So just changing that question changes where things go. But originally, as the question was stated, that's the final answer there. Part J gets a little more complicated. We're going to, on this side, distribute that 2 to the top and bottom, the y and the 8. And then at the end, once we do that, we're going to multiply across the top and across the bottom to combine these fractions. So first one, distribute that exponent of 2. We get y squared over 8 squared. And I'm just going to bring everything else down. We had y to the 8th over 2y. And here we know that y squared and 8 squared, we can combine these on top when we multiply. And that's the addition rule. We have 2 y's and 8 y's. That's a total of 10 y's. On the bottom, 8 squared is 64. So this is really 64 times 2 on the bottom, which is just going right across the bottom here, which is 128 y. But that's not our final answer. If you see, we have 10 on top, 10 y's on top, and 1 y on the bottom. So we would cross off one of those y's on top and bottom, or do the subtraction rule, 10 minus 1, and that's 9. So it'd be y to the 9th over 128. That's our final answer there. Letter K looks a little strange. There's no variables at all, but we'll distribute that negative 3 exponent to the top and the bottom. Becomes 1 to the negative third over 3 to the negative third. And now we don't like any negative exponents, so we're going to basically flip-flop places. Move them up and down, and they change the signs. So 1 to the negative third on top becomes 1 to the positive third on bottom. 3 to the negative third on bottom becomes 3 to the positive third on top. And then we can evaluate all these powers. 3 to the third is 3 times 3 times 3 times, however many times, 3 times, I don't know how many times I said it. 3 to the negative third becomes, or 3 to the third becomes 27. And 1 to the third is just 1 times 1 times 1, which is 1. So this final answer is just 27. That's weird, isn't it? 1/3 to the negative third power. It seems kind of strange that it should be 27, but that's actually the right answer there. Alright, moving right along here. Write without a fraction bar. This isn't my favorite type of question, but you'll see it from time to time. This is just using what we know about negative exponents to get rid of that fraction bar. So basically, in other words, we want to bring everything up. So we're going to bring this up even though it's not negative right now. We'll bring it up and put it on the top. And when we do that, we need to change the sign. So positive 7 exponent actually becomes negative 7. And that's actually the answer there. Doesn't have a fraction bar anymore. I don't want to see this. A lot of people will get creative and do, not that, but they'll do something like this. They'll just 5a and then y to the 7th and just not write the fraction bar. Or people will do this. But those are things that are just kind of creative ways to get around the problem. This is what we're really looking for here. Alright, so next page there. Let's see if I can find it here. Alright, letter A. We have this equation to solve, and the inverse of squaring something is taking the square root. So we got to do that to both sides. Square root of x squared is x, and the square root of 1 over 4 is just the square root of 1 over the square root of 4, and that is 1 over 2, 1/2. In letter B, the cube root of 343 is one that you should have memorized. It's a little bit of a tougher one, but it's 7. So coming into that test, you should have every single one of those flashcards memorized. Those are easy points on that test. Letter C, square root of 0.16. There are 2 decimal places here. So we want a total of 2 in our answer. So we were thinking, what 2 numbers multiply to get 0.16? 2 decimals here, we need 1 for each of these. 1 and 1 would total up to 2. So this answer is actually 0.4. And again, that's because 0.4 times 0.4 is 0.16. But this is just all your thinking. This is the actual answer to the question. Alright, some examples of irrational perfect squares and cubes. Basically, I want to know what numbers can you put underneath a square root or a cube root and get something that can't be written as a fraction. Okay, so basically to get something that can't be a fraction, it has to be any non-perfect square, like 30. Or you could say 21. Anything that's not a perfect square, like 48. For cubes, just anything that's not a perfect cube. So you can't use 1, 8, 27, 64 of those, but you can use any other number, like 3, or you could say cube root of 10, or you could say cube root of 100, because any of those are going to give you a decimal that can't be written as fractions. For rationals, those are a little easier. Just give me the square root of any perfect square. So for example, square root of 100, square root of 16, square root of 49. And it's kind of similar with cube roots, just give me any perfect cube root. So cube root of 8, cube root of 1,000, anything that you have memorized at that point. Alright, And then the last one's easier ones here, ones that we should have memorized. We have square root of 81 is 9. And number 4, the square or cube root of 8 is 2. And again, these are from memory. Cube root of 729 is 9. Square root of 25 on top is 5 over 2. And then 1.44, this is 1.2. Again, 2 decimals here. And then there's 1 in each of these parts because it's really 1.2 times 1.2. So 1 decimal for a total of 2. And number 6, cube root of 1,000 is 10. Thanks for watching. If you have any more questions or if this isn't making sense, definitely come see me in getting ready for your test. Go through those flashcards one more time and practice some more exponent rules. See you guys later.